Hello, my name is Beth Dixon, and this is part 2 of a video series based on Vicki Borlaug's PowerPoint presentation on combinations, permutations, and fundamental counting principle. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos on counting. And I anticipate that there will be multiple parts on this beyond part 2. We are going to now consider counting using combinations and permutations. For other types of counting, we need to use different types of counting, and those would be combinations and permutations. So our goal in our example to introduce these two types is to select 2 people out of these 4 people. So it's to find the number of ways to select 2 out of these 4 people. And we have May, Bob, Ken, and Lee. So here is a list of all the ways to select 2 people. Notice that we have 3 different types of lists. That is because there could be and are different rules that could apply to our selection. Before we can make our selections, we have to decide what parameters we have on our selection. It's almost like the with and without replacement, but it's not exactly the same. So first, let's look at what's different about our 3 lists. Take a minute, or not quite a minute, to study the list. What is different about these lists? First, consider repetitions. Which list allows repetition? List 1 does not allow for selecting the same person twice, nor does list 2. The only list that shows the same person picked twice is list 3, where we have May, then May, Ken, then Ken, Bob, then Bob, and Lee, then Lee. So list 1 repetitions, list 3 repetitions are allowed. List 1 repetitions not allowed. List 2 repetitions are not allowed. List 3 repetitions allowed. That still doesn't explain why we have 3 lists. What else is different about the list? In lists 2 and 3, we have May and Ken, then Ken and May. List 3 also lists May and Ken and May. That's not the same as in list 1. May and Ken is considered different than Ken and May. That means order is important. In list 1, the change of order is not considered important, so Ken and May is really the same as May and Ken, so it's not listed as a different selection. So as we look at that, list 1, order is not important. List 2, order is important. And list 3, order is important. Now, I chose the top names here, but you could do the same by looking at May and Bob versus Bob and May, or any set of names on the list to prove that point. And I hope that explains the differences in the list. This is a vital point to the continuation of this PowerPoint for our counting techniques. Now, it would be very nice if we had a mathematical way to generate the number of names on each list. And guess what? We can't generate the names, but we can calculate the number of names that should be on each list using combinations and permutations and the fundamental counting principle. The first list that we have is called a combination. The notation for that is 4C2. Notice the 4 and the 2 are subscripts. A subscript is smaller and slightly below the written line. Notice that as it's written on the screen. 4C2 gives us 6, and that's 6 names on the list, which matches the number of the names on list 1. List 2 is, I'm sorry, I don't think I had that up there. So look at that again for the subscripts. The 4 and the 2 should be slightly smaller and be listed as a subscript. List 2 is a permutation. 4P2, again the 4 and the 2 as subscripts, gives us 12, and that is the number of names on list 2. List 3 is a fundamental counting principle, and we get that by the number of names and choices that we have, which can be found by 4 times 4, which would be 16, which is the number of names in list 3. Notice the calculator command listed below each list. This is how we will input the numbers into the calculator to obtain the numbers and the results that we need. And we will get to that next. Combinations can be found on the TI-83 or the TI-83 Plus or the TI-84 by following the following steps. Start at the home screen and type 4. That's to tell what the total number is. Then select the Math key, go over to the word probability or the initials PRB, which stands for probability, and then go down and select the NCR. Then type 2, and you should see on your calculator 4 NCR 2. You've typed in 4 for your total, 2 for the number we're selecting out of that, and when you press enter, you should get 6. For permutations, it's very similar. Type in 4, which is the total you're selecting from. Again, press Math, then over to the probability, select NPR, type 2, and then enter, and you will get 12. Now that we understand the list better, let's answer some questions. How many ways are there to select 2 people in list 1? Just to reiterate what we said before, list 1 is the combination, so that is going to be 4C2, or 4 combinations of 2, which is 6. How many ways are there to select 2 people in list 2? That's 4P2, or 4 permutations of 2, which is 12. And how many ways are there to select 2 people in list 3? That would be 4 times 4, which is 16. And to keep the videos relatively short for this set, I am going to stop and pause here, and we will pick up exactly here in the next video. Again, thank you for watching, and if you are a Walters State student, please stop by and see me in the math lab in room 222 of the Math and Behavioral Social Science building.